So man, unit circle, mind blown, right? Well, what if we had, let's do, I know it's probably, who cares about colors? Colors matter. Okay, so let's say that I'm just an angle on the coordinate plane. Yeah, I rotate around, this is theta. It represents an angle measure. Okay, so I rotate around theta degrees, and I'm on a circle, and I don't know anything about the measurements, but I know that I have a right triangle, and we'll call this theta. Theta is our reference angle. Okay, so for our unit circle, notice we've got these different quadrants, but it all resorts back to 30, 45, 60. So if I rotate around my circle to 150 degrees, I don't use a triangle for 150 degrees. I use the reference angle of 30. Why? Because it's how far it is from the x-axis. If I rotate around 300 degrees, I'm not using a triangle for 300 degrees. I'm using a triangle for 60. Why? Because that's the distance between the terminal side, the terminal side and the x-axis. It always relates back to your x-axis. You might want to write that down. It always relates back to your x-axis, and then that's the reference angle we're going to be using. So if I rotate around theta, okay, and well, let's not use theta again. That's a little bit redundant. And then I'm left with a reference angle. We'll call it alpha, or fish, as some of you like to call it. Oh no, we'll keep it theta, because that's what the, oh, fudge. Okay. So then we have, and we're going to keep it theta because of, I just looked at the example on the right-hand side, sorry. So here we are, and I don't know anything, but I do know that this is my radius, right? We're in a circle. The radius is the hypotenuse. I travel negative x units because I'm in the second quadrant, and then I would travel up y units. Well, look at our right triangle in terms of the trig functions. Okay, if I am sine, I am what over what? You are opposite over hypotenuse. So for theta being at the origin, which it should always be at the origin, okay, in standard position, you rotate around the origin, you draw your triangle with reference to the x-axis, never, ever, ever the y. So then we could say that the sine is opposite over hypotenuse. In this case, it is y over r. The y units traveled up or down over the radius. Okay, well, for cosine, it would be x over r, adjacent over hypotenuse. The hypotenuse is the radius of the circle we've rotated around, and then x is how many units we've traveled along the x-axis. For our example, we're in the second quadrant, so you might be thinking, well, why isn't x negative? Well, if I'm in the second and third quadrant, it would be. Okay, and then tangent is opposite over adjacent, so we would say it is y over x. Depending on what quadrant you're in, the y and the x may be positive or negative. Okay, so then cosecant is the reciprocal of sine, which means that it would be r over y. Secant is the reciprocal of cosine, so it would be r over x. And cotangent is the reciprocal of tangent, so it would be x over y. And ladies and gentlemen, these are the general pieces. So if I said to you, okay, there's some point, let's say here, that would be 2, negative 5, find all of the trig functions, we could easily drop an altitude to the x-axis, say that this is my reference angle. We would know that 2 and negative 5 exist. We would find whatever that radius was for that specific triangle. And because of the general ratios, we could then find all the 6 trig functions. It's pretty awesome. Okay, so then what does this mean for our unit circle? Well, for sine of theta, it would be y over r, which, wait a minute, the unit circle, r is 1. So sine of theta is just our y coordinate. That can't be true. What's the sine of a 45-degree angle? It is rad 2 over 2. So it is true. this just got cooler, if that was even possible. Okay, so the cosine is just x. It is the x coordinate. What we can say from that is that on the unit circle, it is written cosine comma sine for every coordinate around the unit circle. Yeah, buddy. A way to remember that is that it's alphabetical. C comes before S, cosine comma sine, pardon me. And then tangent is y over x, which means that it is the sine of theta over the cosine of theta. Sine of theta over cosine of theta. Nice. Okay, so cosecant is 1 over sine. It is the reciprocal, so that means it's 1 over y. I was trying to flip it and reflip it and ignore me. So secant would be 1 over x. Cotangent is y over x, which means it is the cosine of theta over the tangent of theta. That's amazing. It is so cool how much information the unit circle gives us. Okay, so the sine of an angle on the unit circle is the same as the y coordinate. We just discussed that. And then the cosine of an angle is the same as the x coordinate. And the tangent of an angle is the same as the sine of theta divided by the cosine of theta. I guess I could abbreviate to fit it all in there, huh? Think smarter, not harder sometimes. Sweet. That is amazing. Okay, so a couple things. I want to go back to our unit circle. And I would like you to, somewhere on your unit circle, write cosine comma sine in coordinate form so that you can remember that that's what it is. Okay, so that means that in quadrant 1, all of your trig functions are positive because everything's positive. So we're going to say sine, cosine, tangent. I'm going to put none for negative. Cosecant, secant, cotangent. Something else you might want to write on your unit circle is that the tangent of theta is equal to the sine of theta over the cosine of theta, because all this information is so important for us. Okay, so if we know that x is equivalent to cosine, that means that cosine is negative in the second quadrant and sine is positive. Well, if tangent is sine over cosine and sine is positive, cosine is negative, that means that tangent will also be negative in the second quadrant, as well as their reciprocals. And cosecant, the reciprocal of sine, is positive. Okay, in the third quadrant, very good, they're both negative, both cosine and sine and their reciprocals. So if tangent is sine over cosine, and they're both negative. Negative over negative is going to give us a positive. Good. So then tangent and its reciprocal are positive in the third quadrant. For the fourth quadrant, if cosine is positive and sine is negative, how do I know that so fast? Because the coordinates are cosine comma sine, and their reciprocals follow suit. And you have sine divided by cosine for tangent, so negative over a positive. Yep, tangent is negative also. Okay, so taking a look at this big picture here, every trig function is positive in the first quadrant. So I'm going to put an A for all. Only sine is positive and its reciprocal in the second quadrant. Tangent and its reciprocal in the third, and cosine and its reciprocal in the fourth. So ASTC. I don't know, some of you may have heard of that fun little acronym we have, all, because we rotate counterclockwise for positive degrees, right? Oh my goodness, sorry. I'm choking on my spit. All students take calculus. That's how we remember. Now you can think of something else if you're like, that's lame. Okay, fine, judgy. But that is the most common one that we use. Whew, man, so much good information. Okay, remember tricks that we learned about memorizing? Denominators for the coordinates are 2. From the outside, the numerator goes 3, 2, 1. The outside, 1, 2, 3. So as you're extending up or down from your x-axis, that could be something that you use. Okay, so if you go to page 5, and I've been trying to figure out how to rotate this fantastic piece of paper, and I even Googled, and I can't figure it out, so I'm really sorry. Don't worry about the radian coordinate for now. Okay, the radian coordinate does not matter. I know that you probably can't turn your screen. I failed you at this point. I'm sorry. So for 30 degrees, we know that the coordinate is, oh, and it's not red. I needed blue. We know that the coordinate is going to be, from our unit circle, rad 3 over 2, comma, 1/2. So that means that the sine is 1/2 of 30 degrees. The cosine is rad 3 over 2, and so forth. Okay, 45, 60 you can fill out from your unit circle. 90 is at the coordinate 0, 1. So that means the cosine of 90 degrees is 0. The sine is 1 because it's written cosine, comma, sine. The tangent is sine over cosine. So 1 over 0. That's right. It is going to be undefined. Very nice. The cosecant. Okay, here, let's do this. Sine, oh, hello. Let's go back a little bit. Sine is y, cosine is x, tangent is y over x. Cosecant is the reciprocal of sine, so it's 1 over y. Secant is 1 over x, and this is x over y, to help us out a little bit. Okay, so cosecant is 1 over 1, which is 1, and this is still for 90 degrees. Okay, secant is 1 over, again, undefined. Oh, that's fancy. And then cotangent is x over y, which is 0 over 1, which is 0. Nice. Okay, so now that you've looked at this sideways, that's great. What I'd like for you guys to do is fill out the rest of this chart using your unit circle. And I will post the key for this chart in the next couple of days. Okay, fill it out, please, please, please. Also, from our notes on Wednesday, for this special right triangle, I'll post the key for that as well if you'd like to fill in the missing pieces. Okay, awesome. Thanks, guys.